All right, chapter 9 now is we're going to continue our discussion on aldehydes and ketone functional groups. Just to remind you, an aldehyde has a hydrogen on one side of the carbonyl, and a ketone has two R groups, or two carbon groups, on each side of the carbonyl. 9.1 just briefly talks about aldehydes and ketones. They talk about what's called a nucleophilic addition reaction. These compounds do nucleophilic addition reactions where you add a nucleophile to the carbonyl compound. So whether it's an aldehyde and ketone, in this chapter, whatever you do to an aldehyde, you can do to a ketone. Whatever you do to a ketone, you can do an aldehyde. So it doesn't matter if you're adding a ketone or aldehyde. They both do the same type of chemistry. And what you have in this carbonyl is a partial negative on the oxygen and a partial positive on the carbon. So in this chapter, we're going to be adding various nucleophiles to the carbonyl, to the carbon, to break the pi bond, to get these type of intermediates where you add a nucleophile, and always in the second step you're going to add a proton of some sort to turn it into an alcohol. Usually alcohols are the final compounds. All right, so 9.2 is on naming. All right, aldehydes end in al, and ketones end in -one. Very simple. So if you have a 5-carbon aldehyde, it's called butanal. Now, you do not have to tell the reader where the carbonyl is, because aldehydes are always at the end of chains. So you don't have to say 1-butanal or butan 1-al, you just say butanal. So if you have various groups on your aldehyde, let's say you have an aldehyde, let's say you have a bromine, and let's say you have 2 methyl groups here. Carbon 1 is always the carbonyl. Very simple. And then everything else goes after that. All right, so this would be called 2-bromo, 3,3-dimethyl, and we have 5, so it's pentanal. Sorry about that. Pentanal. Okay, so that'd be the name of that compound. Ketones and an -one. Now you have to tell the reader where the carbonyl is, because the ketone could be somewhere in the middle of the chain. It could be at a different place. So there's your carbonyl. Start closest to the side, closest to the carbonyl. So 1, 2, 3, 4, 5, 6. So 2-methyl hexane 3-one. Hexane 3-one. Okay? Common compounds are enones. Enones. I guess enals too, but usually you see them in enones, where you have a double bond and a ketone. So again, start the side closest to the carbonyl. So 1, 2, 3, 4, 5. So this is pent. Sorry, you don't put the "and" in this case because it's a double bond. Sorry about that. Pent 3-ene 2-one. The reason it's an "ene" is first is because E comes alphabetically first. And you don't put the pentan because it's not a pentane. It's not a single bonded molecule. You have a double bond in there, so that "and" becomes an "n." So so it's an enone. Okay, for aldehyde, same type of thing, but you don't have to tell the reader where the aldehyde is. So 1, 2, 3, 4. So but-2-enal. That's how you'd call it. It's an enal. All right.